Hi, I'm Ms. Vung, and today we're going to look at linear relationships and in particular finding the rule. Here we have 6 coordinates. Can you find a pattern? To find a rule, we take 3 steps. First, we think of what operations can we do to the x value to get the y value. Step number 2, we write a rule, and then thirdly, we check that all the points, the rest of the points, satisfy the rule that we came up with. So let's have a look. What can we see here? We can see that 6 to 11 to 16, so the y values are going up by 5. 6 plus 5 is 11. And we can see that that happens as the x values are going up by 1. So we can see there's some form of multiplying by 5. So the x is going up by 1, y is going up by 5, that there's some form of multiplying by 5. So we will write it as 5x. However, when we plug in the x value into 5x, 1 times 5 is 5, we don't get 6, we need to still add 1. So let's check that. So if we have x as 2, 5 times 2 plus 1 is 11. So the rule that we're going to come up, so the rule is y equals 5x plus 1. And then we check the last 2 values over there. When x is 5, will we get 26? So substitute it into the equation. So when x is 5, we get 26. And then when x is 6, do we get 31? Yes, we do. Because when we plug it in, we have 5 times 6 is 30, plus 1 is 31. The same question might be given to you in a Cartesian plane, as in, how do you find a rule for this graph over here? You take the same steps, you think of what operations can we do to x to obtain y. It's easier to look at if we write out some of the coordinates and then we look at the y value. Plus 5, 1 to 6, what do we do? Another plus 5. And looking at the x's, we've gone up by 1, up by 1. So we've multiplied by 5 for each of the y values. So we're doing the same thinking we did before with the coordinates. Now multiplying by 5 is not enough, we have to add 1. So our rule will be y equals 5x plus 1. So it's the same question, but I've given it to you in a different format. Then you always check that the points satisfy the rule. So for example, we can think of, let's say 2 for instance. The value 2 has a y value of 11. So we check 5 times 2 is 10 plus 1 is 11. So it fits. So it satisfies the rule. I could also give you the same question in this format with patterns. Find a linear equation to describe the relationship between the number of hexagons and the number of lines. So 1 hexagon, 2 hexagon, 3 hexagon, 4 hexagons, etc. The number of lines here is 1, 2, 3, 4, so 6. The number of lines here is 11, etc. So we could write a table to make it easier to look at. So x is now our number of shapes and y is the number of sides. And we can repeat the same steps. So what operations can we do to x to obtain y? And because the values are the same, we will obtain the same rule, y equals 5x plus 1. And we would check that the pattern would satisfy the rule. In this case, I would draw 5 hexagons, so one more, the next pattern, and then see if my y values would be 5 times 5 is 25 plus 1, 26. So that's how I would check for a pattern. Here we have another one. You can pause the video and see if you can come up with the equation yourself, and unpause to check for answers. In this scenario, we can see that for every x value, we've added 3 to obtain the y value. So 2 plus 3 is 5. So step number 1, this time we just added 3. So we could write it as x plus 3. So our rule is y equals x plus 3. And last step, we always have to check that the points satisfy the rule. So if we plug x equals 3 in, are we going to get 6? Let's test it out. 3 plus 3 is 6. And if we plug 4 in, are we going to get 7? Yes, we do. So then the rule is y equals x plus 3. Another example, have a go at that one and unpause when you're ready. So what do we do to x to get to y? We can see that we're just multiplying by 2. So our operation is multiply by 2, or in other words, we can write 2x. And our equation is y equals 2x. And lastly, always check Let's see, if x is 10, will we get 20? So plug it in or substitute it in there. So 2 times 10, we would get 20. So the rule works. Y equals 2x. Another one. Again, pause and unpause so you can try it out yourself. Here we can multiply by 3, but we would get 1 times 3 is 3. So we had to multiply by -3. Doesn't work? Well, it works for these three. So our operation is times -3, or in other words, minus 3x. So our equation is y equals -3x. Now we test the last one. So we substitute 10 into x. So -3 times 10, we would get -30. So that's the rule. Y equals -3x. Let's try this one. It's in a table format, but it's the same kind of thinking. When we go from -2 to 6, we're minusing 4, -1 to -3. It's not -4, so we can't go directly from x to y. Let's see if there's a pattern going across the y values. -6 to -3, we've added 3. -3 to 0, we've also added 3. And we can see that the x values are going up by 1. So as x go up by 1, we're adding 3. So in other words, we're multiplying by 3. What else do we need to do? So -2 times 3 is -6. -1 times 3 is -3. We don't have to do anything. So our operation is multiplying by 3, and our equation is y equals 3x. And double check that it works. So let's plug in 1 into that equation, and we can see that it gets 3. And let's try plugging 2 into the same equation. So 3 times 2 is 6. So it works. Our equation is y equals 3x. Let's do an example with a graph. Find a rule that describes the following relationship. So first of all, let's try to find some coordinates so that's easier to read off. So we have this one, and that one over there. Then we have a look at the y values. We can see that we're going up by 6. -4 plus 6 is 2. 2 plus 6 is 8. And what are we going up by with the x values? -2 to 0 is 2. 0 to 2 is 2. So this time, every time we're going up by 2, we're going up by 6 with the y value. So in other words, if we only went up by 1, we would go up by 3. So simplifying the 2 to 6 ratio. So if we're multiplying by 3, will we get the answer? So if we do 0 times 3 is 0, we don't get 0, we got 2. So we have to add 2. Let's try this one. 2 times 3 is 6. Adding 2 gives us 8. So our equation is timesing by 3, but then we have to add the 2. So y equals 3x plus 2. Now we double check, always double check. So let's say we pick 3. 3 going up, we get 11. Let's see, 3 over there. It's this point over here, 11. Well, we get 11. So 3 times 3 is 9 plus 2 is 11. So it works. Always check that your rule works. So to recap, you can look at the x value and see what you did to it to get to the y. In this case, we had adding 3, so the equation would be x plus 3. Sometimes the equation would be, instead of adding, would be multiplying. So you multiply the x to get the y. In that case, we would have the number in front of x. So 2x for this example. And some examples were a little bit trickier, where you had to look at how the y grows as the x grows. And if it does grow consistently, then it's multiplied by that number. But you also have to check that it works. So for this case, remember 1 times 5 is not 6. We had to add 1 more. That's it from me today. Have a go at these questions again and see if you can figure out the rule. See you next time.